This video is about random variables. So a random variable is a quantity whose value depends on chance. Random variables are represented by capital letters, and the actual measured values are represented by lowercase letters. So there are two basic types of random variables: discrete random variables that have a finite or countable number of possible values. Okay, so for example, dice. Continuous random variables that can take on any value in some interval. So for example, the number of chips in a package. So notation wise, these are some examples of ones that you will see. The probability that x equals 3, where x, capital X, is the random variable. Okay. The next one is the probability that x, the random variable, is between 3 and 7. And then the last one, the probability that x is more than 3. A probability distribution for a discrete random variable is a list of each possible value of the random variable and the probability that each outcome occurs. For example, let's take a look at a coin being tossed 3 times. Let the random variable x, capital X, denote the number of heads that occur in the 3 tosses. Tabulate the probability distribution for x. Okay, so we're going to have our start. We're going to draw a tree diagram. So on your first flip, you can either flip a head or a tail, and you've got half chance of flipping either one. Okay. On your second flip, we've got a head or a tail, and a head or a tail. Same thing, half, half, half. And then on your third flip, same thing, head, tail, head, tail, head, tail. This is really similar to the work that we did in the last unit, just some different notation and different charts that we're going to create. So we've got a half for all of those because the next flip doesn't depend on the previous flip. Okay, so what we're going to do next is we're going to create a probability distribution. So probability distribution looks like this. We've got x, which is our possible outcomes. Okay, so we've got a 0, 1, 2, or 3 because our random variable is the number of heads. So in a series of 3 flips, we could get 0 heads, 1 head, 2 head, or 3 heads. So this top row is the number of outcomes. Our second row, the probability that x, capital X, our random variable, is equal to our outcome, little x, is below. Okay, so now we've got the probability of getting 0 heads. So I'll go over that in red. And this would be this pathway here. So tail on the first one, tail on the second one, tail on the third one. So I've got 1/2 times 1/2 times 1/2, which is going to be 1/8. That's my probability. Okay. Let's do the next one in green. So probability for 1 head. So I could flip, I could flip a head on my last one. I could flip a head on my middle one. And I could flip a head on my first one. Those are all the pathways that are going to give me 1 head. So then I would do 1/2 times 1/2 times 1/2 times 3 pathways. So I'm going to get 3/8. Then for 2 heads, I'm going to do the same thing. So I have another 3 pathways. So I could flip a head. We'll start here on my last 2. So I could go tail, head, head. Okay. And then the other two come from my other pathway. So I could go head, tail, head, or head, head, tail. So same thing as my option for one head. I've got 1/2 times 1/2 times 1/2 times 3 pathways. So 3/8. And then my last one for 3 halves, let's use purple because I like purple. Although that's hard to see, let's use orange. Okay, I've got only one pathway, head, 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 which would be my 1/2 times 1/2 times 1/2, which is 1/8. Okay, so this is my probability distribution here. I've listed the outcomes in the top row, and then my probability of the outcomes in the bottom row. Okay, for any random variable, the probability is always in between 0 and 1, and the sum of all the probabilities is equal to 1. So we're going to look at one more example, which is working backwards. So we already know the probability distribution, and we're trying to find out some information about the individual probabilities for each outcome. In this example, the random variable x has a probability distribution shown below. And the first thing that we're asked to do is to find the value of k. So in order to do this, I know that this bottom row has to add up to 1. So I'm going to say that k plus 2k plus 3k plus k has to equal 1. How many k's do I have? Let's see, 1, 2, 3, 6, 7 k's. So that means that k is equal to 1/7. Great. So let's just fill in because I'm going to need it for the other questions. So really my new row looks like this. I've got 1/7, 2/7, 3/7, 1/7. Okay. So now my next question is asking me to find the probability that x is greater than 2. So my probability that x is greater than 2, well, the only possibility in that situation is that my probability of x is equal to 3, right? Because I'm not including 2. So that would just be 1/7. The last one, now I'm looking for the probability that x is greater than or equal to 1. So I could do it, I'm going to do it the long way first. So x is greater than or equal to 1. So then I've got the probability that x is equal to 1 plus the probability that x is equal to 2 plus the probability that x is equal to 3. So I can add all those together. I would have my probability that x is greater than or equal to 1 would be 2/7 plus 3/7 plus 1/7, which would give me 6/7. Okay. Now, a lot of you have probably seen the easier way already. We can look at it sort of the converse and say that the probability of x is greater than or equal to 1 would be equal to 1 minus the probability that x is less than 1, which for our distribution, so probability that x is less than or equal to 1, would be 1 minus the probability that x is equal to 0, which is going to end up giving us the same answer. Okay, either way is fine. They both give you the answer of 6/7. There are some questions on 14A that go with these examples. Good luck.